Hello students, in this video we are going to discuss about gyroscopes and gyroscopic couple. First of all, we will see what is a gyroscope. So gyroscope is an instrument which essentially consists of a rotating disc, that is a rotor, then gimbals and a supporting frame. The main element in this instrument is the rotating disc or rotor, which can spin rapidly about an axis, otherwise known as spin axis. It also consists of gimbals. For example, in this diagram, you can see two gimbals, the first one and the second one. A gimbal is a pivoted support. Here you can see it's a pivoted support that allows the rotor to rotate about a single axis. So here there are two gimbals which will allow the rotor to rotate in two different axes. And the whole setup is mounted in a frame. Now we will see what is the basic working principle of a gyroscope. The basic working principle of a gyroscope is gyroscopic couple, or otherwise known as gyroscopic effect. So the gyroscopic couple, the concept is very simple. That is, if you try to change the orientation of this spin axis, that is, if you are changing the position of the spin axis, that is by giving an angular motion to the spin axis about a different axis. Okay, so if you are trying to give an angular motion to this spin axis about another axis, then the rotor or the rotating disc will tend to resist or will provide a resisting torque, otherwise known as gyroscopic couple. So for any change in orientation of the rotor axis, the gyroscope will offer a resisting torque, which is otherwise known as the gyroscopic couple. And also remember, one of the most important terms associated with this gyroscope is known as precision. Precision is nothing but the angular motion that is given to the spin axis. And the axis about which the angular motion is provided is known as the precision axis. Right. Now, we will see what is a or what is gyroscopic couple in detail. Okay, so also remember that gyroscope instruments are widely used in navigation systems, especially in aircrafts, ships, and many gyro sensors are used in smartphones nowadays. So those are one of the application of this instrument. Then, okay, now we will see what is gyroscopic couple in detail. For that, please look into this diagram. In this diagram, you can see there is a rotating disc or a rotor, which is spinning in counterclockwise direction about x-axis. Also to be remembered is that it is very essential to specify the direction of viewing while studying this gyroscopic couple. So here the direction of viewing is clearly specified. It is from the positive direction of x-axis. So according to the direction of viewing given here, you can see that the rotor is spinning in counterclockwise direction. Now we will see the details of the three axes specified here. The first one is, as I said, it is the spin axis about which the rotor rotates. The second one is the precession axis, that is the y-axis, where you can see that by rotating the y-axis in counterclockwise direction here, you are giving an angular motion d theta to the spin axis. In other words, you are giving a precessional motion to the rotor axis. Okay, so the second important axis is the precession axis, which is the y-axis. Now we will see the importance of third axis. That is, by undergoing precession about the y-axis, that is, by giving an angular motion to the rotor axis, there will be an active torque acting on the disc about the third axis, that is the z-axis. And equivalent to the active torque, that is equal in magnitude but directionally opposite, there will be a reactive torque or couple acting about the same z-axis, which means an active action and reaction couple will be occurring about the third axis, and this axis is otherwise known as couple axis. So please look into the details of the axis. First one, spin axis, about which the rotor rotates. Second one, y-axis, about which the angular motion of the spin axis occurs. And the third one, the couple axis or the axis of gyroscopic couple, where the active and reactive couple occurs due to precession. Okay. Now we will see why this active and reactive couple occurs. So in order to have a better understanding, please consider a body in rectilinear translation. That is, consider a body of mass m and uniform velocity v moving in a straight line. In order to change the direction of motion of the body, you essentially need a force, right? Because it is the basic Newton's second law of motion. So based on Newton's second law of motion, if you want to change the momentum of a body, you essentially need a force. So the same case can be considered here also. Here you can see that instead of a body in straight line, we are having a rotor which is in rotational motion. And it is having an angular momentum in or along x-axis. It is having an angular momentum along x-axis. And if you want to change this angular momentum, or if you want to change the orientation of this axis, you essentially need a torque. So in order to change the angular momentum, you need a torque, because by changing the angular momentum, corresponding to the change in angular momentum, there will be an angular acceleration, and that is alpha. And corresponding to the angular acceleration alpha, there will be a torque, and that torque is called active torque or active couple. And If there is an action, definitely there will be a reaction. And that reaction torque or reaction couple is known as gyroscopic couple. So this active and reactive couple concept is quite similar to the concept of centripetal and centrifugal force in rotating bodies. So if one is action, the other one is reaction. They are equal in magnitude, but direction opposite. Okay, so this is the basic idea of why this active and reactive couple occurs due to change in angular momentum. And now we will see. There are certain important things to be discussed here. That is, one thing is, how come you know that this is the direction of angular velocity or angular momentum? Or how can you find that this is the direction of angular velocity or angular momentum? For that, we will follow one of the famous rules that we had followed in our earlier physics class, science classes, and that is the right hand rule. So in order to review that right hand rule, we will see the following diagram, this one. So as name indicates, for right hand rule, you please use your right hand. So take your right hand and curl the fingers of a right hand in counterclockwise direction. That is the direction or the sense of rotation of your disk. Here, the disk is rotating in counterclockwise direction. So curl your fingers in the same direction, the counterclockwise direction. By doing so, your thumb will be pointing towards the direction of angular velocity vector, which is omega. So, right hand rule is very simple. You can curl your fingers in the direction of rotation of your disk or rotor and hold your thumb upright, and that will be pointing towards the direction of the angular velocity vector. As I have said, we are dealing with bodies in rotational motion. So we are having the angular momentum, that is capital H, which is equal to I. I is mass moment of inertia into omega, which is the angular velocity, right? Where I is the mass moment of inertia of the disk. I is equal to mk square, where m is the mass of the disk and k is the radius of gyration, and omega is the angular velocity of the disk. So by knowing the direction of vector omega, you can understand that it is the same direction of angular momentum h. So the direction omega that is shown here is the same direction of the angular momentum. Okay. Now going back into our actual diagram, this one. So now you can easily do the exercise of your right hand rule. So take your right hand and curl your fingers in counterclockwise direction, because this is your direction of viewing. That means you are standing here, and curl your fingers in counterclockwise direction, and your thumb will be pointing along OX, right? So this will be the direction of your angular momentum, right? So do it as a practice exercise. So it will be like this, right? You can check it. So curl your fingers in counterclockwise direction, and the thumb will be pointing towards your face. So check whether it is right. Okay. Okay. So now we are going to give the precessional motion according to the right hand rule. Okay. So before giving the precession, now the your right hand thumb is pointing towards your face, that is along OX axis. Okay, fine. We are giving precession about to y-axis in counterclockwise direction as indicated here. All right, that means you will be rotating your right hand such that your thumb will be rotated from OX towards OZ prime. Okay, so your thumb will be rotated from OX to OZ prime. Please avoid this straight line while understanding. Right? It's just an error. So please avoid this straight line. Okay, so basically you are rotating your thumb from OX to OZ prime. So now your right hand thumb is pointing towards OZ prime. That means you have given precision to the angular momentum vector. That means the angular momentum changes. When angular momentum changes means definitely there will be a torque. There will be a corresponding, that means the angular momentum changes means angular velocity changes. Angular velocity changing means there is an angular acceleration curve alpha corresponding to which there will be a torque, and that torque is called active torque. So now your right hand thumb is pointing towards Z prime, and I hope your fingers will be curled in clockwise direction about Z axis like this. If you have done it correctly, your fingers will be in clockwise direction about Z axis. That means the curl of your fingers will give the direction of active torque or active couple. So if you are able to find the direction of active couple using a right hand rule, so definitely you can easily find that the direction of gyroscopic couple will be in counterclockwise direction, which is opposite to the active. So this is how you will find the direction of gyroscopic effect using a right hand. So once again, I am remembering you, please avoid this straight line for your understanding purpose. This is just an error while doing my video, so please avoid this. Okay. So I hope you understood how to apply the right hand rule to find the gyroscopic direction of gyroscopic couple. Right. Now we will move forward. We will see some of the important planes associated with this diagram. That is the first one, XOZ plane. That is the most important plane. This one, X. Oh, here it is not Z, it is actually Z prime, right? Okay. Anyway, this XOZ plane, which is the precessional plane, right? The precession plane. About y-axis, you have given the angular motion, but the precession occurs in XOZ plane, right? So this is the plane of precession. And YOZ plane, that is YOZ plane, you can see here, YOZ plane is the plane of spinning of the rotor. That is the plane at which the rotor spins. While viewing from this side, you can see that YOZ is the spinning plane. And the last one, that is XOY plane, which is the couple plane. This one, this is the couple. This was the spinning plane, YOZ plane, and now XOY is the couple plane or the plane of gyroscopic couple. That is, here you can see the two couples, that is the action and the reaction couples, can be easily projected on XY plane. Easily projected on XY plane. So remember, about Z axis couple occurs, but The couple plane is xy plane. Okay, hope you understood. So every plane is perpendicular to the other two planes. Very obvious sentence. Fine. Now we will move forward to the textbook definition of gyroscopic couple, which is CG. C stands for couple and G stands for gyroscope. So the definition is, if the rotating disc or the spinning rotor is given an angular motion, that is the precessional motion about y-axis, which is perpendicular to the spin axis, that is x-axis. So if such an angular motion is given, definitely there will be a change in momentum, which will induce an angular acceleration, right? An angular acceleration will act on the rotor about the third axis, which is z-axis. And corresponding to this angular acceleration alpha, there will be a torque, and that torque is called active couple. And for every action, there will be a reaction from the body, that is from the rotor, and that is called the reactive couple of gyroscopic couple, otherwise known as gyroscopic effect. As you know, couple or torque, the unit is Newton meter. Okay, so now we have discussed the concept of gyroscopic couple. Now we will see the first portion, that is how to find the magnitude of this gyroscopic couple and how to draw the vector diagram of this precessional motion or the gyroscopic effect. First of all, we will see the figure A, that is this figure, and we will see how to draw the vector diagram. So from this diagram, this is the direction of viewing, you can see. So this, from this direction, when you view the spinning of the disc, you can see that the disc is rotating in clockwise direction. So again, use your right hand rule to find the direction of angular velocity or the angular momentum vector. So if this is the direction of viewing, curl your fingers in clockwise direction, and I hope your thumb will be pointing towards this direction. Now OX, that is, it will be, the thumb will be pointing away from your face. Okay, if you have done it correctly. Okay, so this is the direction of what you call the angular velocity vector, or omega, which is same as that of the angular momentum, right? So OA indicates direction of angular velocity. Now in the diagram, it is given that the rotor axis or the angular momentum vector is given a precession or angular motion about y-axis. About y-axis. About y-axis, the precession occurs in counterclockwise direction, that is from OX to say OX1. And now this omega change, that is the angular velocity or the angular momentum, changes from, I am saying that angular velocity and angular momentum changes means both are same, because I doesn't change, only omega changes, right? Okay, so by doing this precession, this omega changes to omega plus what you call the d omega. Okay, because you are giving a precession d theta about y-axis, right? You are giving a precession d theta about y-axis. So now that means this omega changes to omega plus d omega. That means this will be the direction of the angular velocity after precession. As you know, this change in angular velocity occurs due to the active torque. Active torque is nothing but vector AB, active torque. And this, so basically this d omega is due to this active torque that is indicated by the active AB. So AB denotes the active couple. Vector AB denotes the active couple. And if you know the direction and magnitude of active couple AB, definitely you can find the reaction torque, which is BA. So reaction torque is nothing but vector BA. Vector BA is the reaction couple or the gyroscopic couple. So while understanding this vector diagram, it is essential to know that vector OA and OB are the vectors in X, O, Z plane. Z plane means Z prime plane, right? That is in the precession plane. While these two vectors, that is vector AB and vector BA, that means the action and reaction. Okay, fine. So basically this couple is in XY plane. So in this vector diagram, you can see the vectors in two different planes. Okay, you can see the vectors in two different planes. Vector OA and OB are the vectors in precession plane. Which is the precession plane? X, O, Z prime plane. And the active and reactive couple, that is vector AB and vector BA, the opposite one, right? The opposite vector. They are the couple vectors which are acting in XY plane. So remember that. Okay, so this is the vector diagram corresponding to the gyroscopic effect. So usually it is asked in solving gyroscopic problems. So please study it well. Now, finally, we will see how to find the magnitude of gyroscopic couple, and this equation will help you to find the magnitude of gyroscopic couple in Newton meter. So, in this particular video, I am avoiding the derivation part of this particular equation. I am only using the end result, which is I omega omega p, where I, as you know, it is the mass moment of inertia of the disk, which is mk square. Omega is the angular velocity of the disk, which is nothing but 2 pi n by 60, where n is the rotational speed of the disk. And omega p is the precessional angular velocity. P stands for precession. Precessional angular velocity. So that is nothing but V by R. For that, just to take a simple example. For example, if you are studying the gyroscopic effect in any one of the automobiles, for example, if you take the case of your four-wheeler, I think I have forgot to explain that sentence in the previous slide. Here, the first point. See, the gyroscopic effect are very common in automobiles, especially automobiles having rotating elements. There are wheel, engine shaft, etc., which will undergo this gyroscopic effect when they are taking a curve or when they are taking a turn. That means they are undergoing precessional motion. So consider that you are driving your four-wheeler and the wheels are having certain angular velocity omega, and at the same time you are taking a left curve or a right curve or a left curve of radius, say mean radius capital R, with a uniform velocity v. So if you are taking a turn or a curve of mean radius r with a uniform velocity v, then omega p, the precessional angular velocity, can be easily determined using by the relation omega p is equal to v by r. So you can easily find v by r if you know v and r, and the other terms are also known to you, so you can find the gyroscopic effect. CG in Newton meter. So I hope you understood how to find the gyroscopic effect. What is the concept of gyroscopic effect? How to find its magnitude and how to draw the vector diagram. Thank you for viewing this video.